Just before I start, can I ask just for a show of hands of people who are looking at building sort of private cloud infrastructures to start with? Okay, a couple of you. And any particular networking-centric individuals in the room? Or most of you application-type people or whatever? So no networking people. Good. I'm right there with you. So, can I, a final show of hands before we start then, can I also ask how many people have heard of Arista networks before? 2, okay, good. Well, if you see our exhibition stand outside, you will realise that we're a very engineering-led company and less of a marketing company. But hopefully we'll get over the main principles of what our approach to networking for the modern cloud data centre is throughout the presentation. But for just those people who haven't heard of us, you've probably heard more about the people behind Arista maybe than the company. As an organisation, we were only founded back in 2004 and didn't start shipping product till 2008. So 4 years of pure R&D went into the company product range before we started shipping, which is quite unusual in this world of startup organisations based on venture capital. Arista is quite unusual in the fact there's no venture capital. We're purely funded by our founders. And so what that enabled us to do was to spend a period of time doing the R&D behind the architecture of the platform to get it right before we actually started shipping. A luxury not offered to any company that's got venture capital who are forced to chase revenue. I'll mention something more about the management team, who you will have heard of before. We've currently got over 1,600 customers globally. We've shipped our millionth Ethernet port, and our primary goal is in the driving of the adoption of 10 gigabit Ethernet, 40 gigabit Ethernet, and beyond up to 100 gigabit Ethernet, but purely for the modern data center. So you won't be hearing anything about wireless networking, power over Ethernet, campus infrastructures. We're purely building Ethernet switches for the modern data center and the modern cloud data center. And surprising to be talking about being number 2, to be proud to be number 2, but considering nobody's actually heard of us before, I think it's quite an achievement already to have got to that stage when there's such big, well-known organisations operating in this field. So just to give you some background, and sorry for the top of the slide being clipped here, but you will have come across, in fact, you will have been following the careers of the people behind Arista. If we start with Andy Bechtolsheim, Andy was the founder of Sun Microsystems back in the day. He then joined forces with David Sheraton, who is still Professor of Computer Sciences at Stanford, and they formed their first company, Granite, which they sold to Cisco, which became the Cisco 4000 range. They went on to found other companies such as Kelia, which they sold back to Sun Microsystems. But if you've not come across Andy from Sun, and you've not come across Andy and David from Granite, you will have come across a company that they put the original money into, which was a company called Google. And luckily that success has led to them having the financial opportunity to fund Arista from scratch without the need for venture capital. The other person that's worthy of note is our CEO, Jay Sri Alal. For those in the networking sphere who know Cisco, will probably be aware of Jay Sri as she ran their entire data center routing and switching platform for several years with a revenue stream in excess of 13 billion. The point I'm trying to make with showing you the background to Arista is the fact there's a huge amount of knowledge, experience, and industry connections based on the founders of Arista, which is obviously important for a startup organisation as we were back in 2008. Arista's business is split at the moment 3 ways. We do a lot in the financial services and high-frequency trading, but the fastest 2 growing areas of our business is in providing infrastructure for the cloud service providers, and increasingly for large to medium-sized enterprises building out cloud-based data centers. And to give you a flavour of some of the people that we work with, again, you've not heard of us before, but our install base is considerable. And certainly from the perspective of this, for this audience today, it's worthy of note that the majority of the large service provider-based cloud infrastructures are based on Arista, whether you're talking about the likes of Tata, Korea Telecom, Singtel, Verizon, AT&T, Deutsche Telekom. All these organisations have built their cloud infrastructures based on Arista. And what we're seeing increasingly is now that relevance to those service providers is applicable to the large and medium-sized enterprises entering a similar sphere. So apologies if I keep looking over my shoulder. I've got to remind myself of the slides, and unfortunately there isn't display in front of me here. But if we look at the types of challenges that are evident in the modern data center, the first thing is the data center itself is a very expensive place to be. Whilst us at Arista building Ethernet switches, we love the idea of Ethernet switches having a value, but really that's not why data centers are there. Data centers are there to host servers that provide applications and services to the clients. The networking in some ways can be looked as an overhead. So space and power consumption of the network needs to be limited as far as possible to maximize the number of servers that can be deployed in an environment that's very expensive to own and manage. Second thing is with cloud is the absolute reliance on virtualization technologies. And from a networking perspective, there's certain things that challenge the network from a virtualization perspective. Those primarily being things like the increased I/O that you see through the application servers. As you shrink the number of servers and maximize their utilization, clearly you're going to see a higher rate of I/O. And that's primarily one of the drivers behind the adoption of 10 gigabit Ethernet in the modern data center. The other things are, from a virtualization perspective, is the massive increase in the number of VLANs that people require and the number of MAC addresses that are required to support these technologies. And finally, for those people involved in networking, also the dilemma of do we build layer 2 only networks or do we build layer 3 networks or combinations of the two. Another thing that's clear, and we'll talk about this in more detail in later slides, is that application architectures are changing. If we look at the traditional data center, it was built around very much client-server models where a single application will be hosted on a single server, and a client would communicate directly with that server, thus leading to a traffic flow of about 80% of the traffic traveling between the server and the client, and about 20% of the traffic remaining in the data center. That's a model that's fundamentally changing in the modern cloud environment as application architectures change. And finally, automation. As these infrastructures get bigger and more critical, the way that costs can be reduced is through automation. And the way that speed of deployment and flexibility can be gained is through automation. And obviously one of the key terms that's being bandied around in the industry at the moment is software-defined networking. And that's becoming an increasing challenge for most network infrastructures in the modern data center. So as I say, this is a traditional architecture of a data center network that was deployed 5 or 10 years ago. Very much a hierarchical infrastructure supporting the data flow between the client outside of the data center and the application-based server in the data center, where traffic flows again, typically about 80% of the traffic going to the client and only 20% of the traffic remaining in the data center where it's being processed. What we're also seeing, I'll talk about this in more detail slightly later in the presentation, but the nature of the switches that are the Ethernet switches being used in the data center is evolving dramatically. As we see a tie-in between the applications and services running on the network and the physical network itself. Traditional operating systems running on very small limited processors and switches, limited the ability to integrate the physical network with the applications and services running on it. That's a challenge that needs to be overcome. So what I thought might be useful for you is just to give you an insight into some of the market dynamics that are going on in the Ethernet switching world. Can I just ask, how many people have come across Moore's Law before? Yeah, good, okay. So as you're aware, Mr. Moore back in 1965 determined that realistically over the next 10 years that the processor would double in performance every 2 years. Well, he's been proven right beyond his wildest dreams, and that continues today. And as you can see, it's a very linear line in terms of the development of processor and the advancement of processor technologies out there. What is, however, clear is that while the processor has increased over the last 40 years by a factor of about 1 million, the network hasn't. And the network is in danger of becoming the bottleneck in between the server and the applications and the storage and ultimately the client. Because the network has really stepped up from 10 meg up to 10 gig. which is nowhere near the rate of increase in performance of the processors operating in the servers. So the network is in danger of becoming the bottleneck in terms of the infrastructure. So what are we seeing out there? We're seeing things like the adoption of 10 gigabit Ethernet. Are people seeing 10 gigabit servers coming through for their data center infrastructures? See a few nods of the head. Well, if you follow the market predictions of most of the major analysts, 10 gigabit Ethernet connected servers will become the standard within the data center over the coming 12 months. That's primarily driven by some of the developments by people like Intel. So Intel, with the X540 LAN on motherboard chip, means that the majority of servers will ship as standard with 10 gigabit Ethernet inbuilt into the server. So why not make the most use of it? Another key challenge in the data center is also the life expectancy that people have of the various aspects of the infrastructure. And here clearly we're looking at the cabling plant, the switching infrastructure, and the server infrastructure. Because of Moore's law, it's quite acceptable now to consider a server to have a lifespan in a modern data center of around about 3 years. People will typically look for the Ethernet switching infrastructure to last about 5 years, but still the cabling plant, the cabling, the connectivity between all these elements is typically asked to exist for between 10 to 15 years because of the cost of deployment. So what we'll see as a natural output of that is that a variety of things will change in terms of the usage of networking in the data center. What you can see from this slide here is this is an overall market share of the various different technologies used. And as you can see, the purple space at the top there is the adoption of 10 gigabit. This is across campus and data center initially. But you can see is the average spend or the spend on networking technology will become almost equal between 10 gig and 1 gig over the coming 12 months. What's increasingly important, though, is in terms of the data center, the majority of servers will now become 10 gig connected. What we also see within the data center is the number of servers shipping with LAN on motherboard, 10 gig connectivity. And finally, an interesting point as well is the adoption of 10 gigabit Ethernet over unshielded twisted pair. So if we go back to this model that we talked about before of the server lasting 3 years, the network lasting 5 years, and the physical cabling infrastructure lasting 10 years and beyond, the adoption of 10 gig base T becomes a natural opportunity for most people. Because in the lifetime of the switch, in the lifetime of the cabling infrastructure, you will see a refresh of the server multiple times, and you will see a refresh potentially of the switch. So deploying a switch that can accommodate your 1 gig connectivity today, as well as your 10 gig connectivity of the future, in the lifespan of a switch, actually does make cost-effective sense even today. So I think from these figures, these facts and figures, what's clear is the modern data center will become a 10 gigabit Ethernet environment and migrating into 40 gig and 100 gig over a short period of time. The other thing that's clear is that Ethernet is going to win the day. I've heard this sort of described as a comparative situation between Betamax and VHS in the good old days. Was Ethernet the best technology? Was VHS the best technology? It doesn't really matter. The technology is going to win. And that's primarily because of its price point and its simplicity. But what we're going to see is the modern data center will increasingly become an Ethernet-only environment. Technologies such as InfiniBand and particularly fiber channel over Ethernet and fiber channel itself will become increasingly marginalized in terms of their deployment, purely through a cost and simplicity perspective. So, what's different about Arista as a vendor? Well, I think it's primarily the fact that as a company we started our product development in the 2000s and not back in the 80s. And that gave us an ability at that point in time to look at the way that modern technologies were going and the way that modern infrastructures needed to be built. And that was clearly the dawning of the sort of the first early discussions of sort of cloud and modern data center infrastructures. So very early on, we decided that we were going to make use of off-the-shelf silicon. We weren't going to become a silicon vendor ourselves, but what we were going to become is the master of an operating system. an operating system that was uniquely open and extensible so that we could tie our physical switches into the applications and services that people wanted to use. And the best analogy I've ever heard used in this case is it's rather like Formula One, where on the grid there might be 4 or 5 different people or different teams with exactly the same engine. However, it's the engine management systems, it's the way the engineering is done of the overall car that makes a difference between success and failure. And that's the way that we believe that building Ethernet switches is going to differentiate Arista. Second thing is we realised that, back to this point about the way that modern applications are architected and delivered. And the best example I can come up with is that of Facebook. Everybody can have a very useful and an effective user experience of Facebook, even from a mobile phone over 3G. Why is that? Well, the way that the application is actually written is that 80% of all data actually remains in the data center and never leaves there. It's a very lightweight request from the client to the data center. The data center then crunches all the information about what somebody was doing last night with who, why, and wherefore, and then consolidates that information, renders it into a format that's suitable for the device that requested it, and then posts that information back. If you look at the way all applications are beginning to be written and architected, that's exactly it. So the modern data center has actually got to cater for 80% of this data purely existing in the data center, being sent between maybe a front-end web server, between application servers, between databases, and then being crunched and then consolidated back and rendered back into a format that's trickled back down to the client. That's the way all applications are being done. So no longer those hierarchical data center network architectures that we showed before are acceptable for delivering those kinds of services. These networks of today have got to be very, very predictable, very, very flat in terms of 2-tier architectures that can scale horizontally to meet the needs of the servers, applications, and storage devices that need to be connected. A fundamental change in the way that architectures are built. To give you a bit more about Arista, I mean, an Arista switch is in fact a Linux server. So unusually, as a switch vendor, we built it on a standard format of an open distribution of Linux. The idea is that that's an environment that everybody in the data center is comfortable with. It also enables us to build this highly modular operating system. And the reason we want it to be modular is it's very, very resilient and reliable and easy to extend the scope of what it can do. The other reason is, as things like OpenStack and OpenFlow become increasingly important to these cloud environments, our operating system is extremely easy to integrate with those platforms rather than the traditional unmodular operating systems that traditional network vendors have done. The whole idea here is to make it integrate into the applications and services so that we can start to automate the infrastructure. So anybody in a networking world would recognize our command line. It looks extremely like Cisco. But equally, anybody who knows Linux will also be able to type bash on an Arista switch and get into an operating system, run applications and services, and also modify and integrate the way the operating system works to serve their needs. Ultimately, you can get more out of the switch, the more open and extensible it can get. So a good way of demonstrating the power and the flexibility of this, one of our clients, our large clients, is eBay. And eBay set us a challenge of how can they deploy a new rack of servers in under 15 minutes without any skilled engineers on site. So what we've actually been able to do is use the underlying Linux as well as the power of the switch. And effectively what happens when the switch boots up, what first of all happens is a company builds the rack with all the bare metal servers in it and a top of rack switch. That then is wheeled into the data center on demand and bolted to the floor, and fiber optics are connected to the switch. Switch goes off and configures itself automatically across the network. It also then turns itself into an FTP server and a TFTP server, Pixie boot server, and it downloads all the configurations of the servers. Then the server boots the switch boots all the servers in the rack. Thus, there's actually no need for any technical staff on site. That means they can deploy these servers very, very quickly, on demand, without skilled technical staff. They can run a data center of over 100,000 CPUs with only 5 people working shifts. That's how they can automate the platform. That's how they can minimize the cost of administration operation. And I realize that eBay may be an extreme example of what can be done, but this is equally applicable to your small, medium, and large enterprise as it is to a large service provider. It's just a good demonstration of what's possible. So from that, just to give you an idea of what we build Ethernet switches. They come in a range of sizes, from the very small to the medium to the very large. Currently we're shipping up to 1,100 10 gig Ethernet ports in 11 rack units in a single switch. So from the very big, but equally down to 24 ports in a 1 RU. So we've got a range of platforms. An interesting point that we set out from the very start was that we wanted a single binary image running across all the switches. So even if you buy into one of the entry-level 24-port switches, you get exactly the same performance, capability, and feature set on that switch as you do on the larger modular-type switches. So again, we're trying to make this applicable, not just to the very large enterprises and service providers, but equally bring the relevance into the smaller and medium-sized organizations as well. And I feel as though I've raced through this, which hopefully buys everybody a little bit more time to get coffee and everything else. But really, just to summarize some of the key points as we see it from a networking perspective in the modern cloud environment and the modern data center, those are primarily Ethernet will win. You might not agree that it's the best technology, but ultimately it is going to be the technology of choice in the modern data center. The migration from 1 gig has already started. If you start to try and ignore 10 gig, you'll do it at your peril, because inevitably it's going to be part of the servers and storage devices that you're going to buy. So why not make use of it? And investing in switching that supports 10 gig at this stage will ultimately save you money, even at this stage, even though there's a premium to be paid for it currently. Networks have fallen behind the capabilities of the servers. Moore's law has demonstrated the rate of increase in terms of performance of the servers and the CPUs. With 10 gig Ethernet, we're beginning to address that. 40 gig is already shipping, and we're seeing the early variants of 100 gig. This will only seem to increase, particularly in specific elements of the network in the data center, storage being one of those primary devices that will connect at high speed. Then, traditional network architectures don't scale, don't meet the needs of the modern applications that are hosted in the modern data center. Application architectures are changing, and the network needs to change to meet those. And also, finally, the modern cloud environment, whatever derivative you decide to look at, it does need a tighter integration between the physical network, the applications and services that you're going to run on it. Automation is crucial, otherwise costs will become prohibitive. And so having open and extensible platforms that are easy to integrate will ultimately reduce cost and speed up time to market.